Hello friends, welcome to this session. Today we learn about the thermometer and the concept of thermometry. Before introduction of the thermometer, first of all we know to concept of heat and temperature. If we heat one end of a metal rod and touch the two ends, we find one end hotter and the other end cooler. In scientific language, we say one end of the rod is at a high temperature while the other is at lower temperature. Thus, the temperature of the body measures of its relative hotness or coolness. It is a common experience that if a body receives heat, its temperature increases, and if it gives out heat, it cools. Further, when two bodies, say A and B, are put in contact, the heat start flowing from the body of higher temperature, say A, to the body of B temperature, that is the lower body temperature. This continues till both appear equally hot or equally cold. That is, they attain equal temperature. This is known as the state of thermal equilibrium. The thermal equilibrium is defined as the state in which two bodies in contact they attain the same temperature. In this state, the further flow of heat stops. The situation is similar the as the situation is similar to flow of charge from higher to lower potential, or the flow of liquid or a fluid from higher pressure to lower pressure, or the flow of the liquid from higher to lower level. The heat also flows from higher to lower temperature. The flow of heat from one body to other, it depends upon their temperatures or degrees of hotness and not on the total heat contents of the bodies. Thus, the temperature may be regarded as something that decides the direction of flow of heat from two bodies and brought into contact. The concept of temperature is also evolved from the thermal equilibrium. If two bodies are in thermal equilibrium, they must have some common property equal. To this property, we call the temperature. Heat also is the form of like electricity, light, sound, etc. Whenever there is a transfer of heat or energy between two bodies due to difference in their temperatures, the energy so transferred is called thermal or heat energy. Or in simple language, the transit of energy is heat. The temperature of a system can be defined as The property that determines whether or not the body is thermal equilibrium with the neighboring system. If a number of systems are in thermal equilibrium, this common property of the system can be represented by single numerical value called the temperature. It means that if two systems are not in thermal equilibrium, they are at different temperatures. Measurement of temperature of a body accurately is one of the most important branch of heat in physics. It also becomes necessary to measure high temperatures and low temperatures. To make this measurement possible, it is essential to contact a suitable scale of temperature. The scale can chosen must be precise and consistent, and the temperature measured on the scale must be accurate. So a thermometer is introduced to measure the temperature. A thermometer is a device that is used to measure the temperature of body. There are different types of thermometers. First is the liquid thermometer. These thermometers are based on the principle of change in volume of a liquid with a change in temperature. Mercury and alcohol thermometers are based on this principle. Gas thermometers. These are based on the principle of change in pressure or volume with change in temperature. Example, calendars contact constant pressure thermometer, constant volume hydrogen thermometer, etc. Then the resistance thermometers. These are based on the principle of change in resistance with change in temperature. Platinum resistance thermometer is the example. Thermoelectric thermometers. These are based on the principle of thermoelectricity, that is production of thermoelectromotive force in a thermocouple when the two junctions are at different temperatures. The various thermocouples commonly used like copper constantan, chromel constantan, platinum and rhodium, iron and constantan, chromel and aluminum are uses in thermoelectric thermometers. Then vapor pressure thermometers. These are based on the principle of change of vapor pressure with change in temperature. These are used to measure the low temperatures like helium vapor pressure thermometer. Bimetallic thermometers. These thermometers are based on the principle of expansion of solids. A bimetallic strip is taken in the form of spiral. Its one end is fixed and the other end is attached to the long pointer. The pointer moves on a scale calibrated in degrees. These thermometers are used in meteorology for recording the change in temperature during the day. They are also used to measure the temperatures at high altitudes. The magnetic thermometers. These thermometers are based on the principle of change in the susceptibility of substance with temperature. These thermometers are useful for measuring the low temperatures near the absolute zero temperature. The radiation thermometers, these are based on the quantity of heat radiations emitted by body. Example, furnace. These instruments are known as pyranometer. These are the different kinds of the thermometers. Liquid thermometers are used in medical or clinical thermometers. The laboratory thermometers, the digital thermometers. These are the used in our laboratory. This liquid thermometers is used in medical line to measure the body temperature. Most of the thermometers, most of these thermometers made in the 20th century are mercury thermometers. They are sensitive and accurate, having narrow place where the level of mercury rises very fast. A kink on the tube stops the mercury level from falling on its own. These kinds of thermometers are used in the clinics by the doctors, so they are also called as doctor's thermometer. It is used to measure the human body temperature in the range of 35 degrees Celsius to 42 degrees Celsius. Laboratory thermometers are used to measure the room temperature of the hot solids and liquids in experiment. It measures temperature in the range of 5 degrees Celsius to 110 degrees Celsius and on higher temperatures also. Digital thermometers measure the temperature by means of electronic circuit. The information they capture is sent to the microchip that processes it and displays it numerically on the digital screen. They are easy to use, fast, accurate, and inexpensive. These are the advanced thermometers used to measure the temperature of the body of a high level of accuracy. How to use digital or clinical thermometers? In order for the body temperature to be measured correctly with the digital thermometer, the following steps must be taken. The first, turn on the thermometers and check if the number 0 appears on the display or a low display is on the screen. Then place the tip of the thermometer under the armpit, mainly to measure the temperature of body. Next, wait a few seconds until you hear the thermometer alarm. Remove the thermometer and check the temperature value on the screen. Some infrared thermometers are there. Nowadays, in COVID pandemic situation, thermal gun is used to measure the body temperature. The mercury thermometers, it has a linear expansion property and has a temperature range minus 35 to 500 degrees centigrade with compressed nitrogen. It works on the principle delta L is proportional to delta T, where delta T is the delta L divided by log of alpha, and alpha is the linear expansion coefficient. Mercury thermometers is contradicted due to the health risk such as respiratory problems or skin damage. But there are also currently glass thermometers similar to the old mercury called analog thermometers, which do not have mercury in their composition and can be used safely. This type of thermometers takes longer to measure the temperature than the others, and the reading is usually more difficult to do. Alkaline gas thermometers made from sealed gas and sealed glass, it displays the temperature by the level of at which mercury or alcohol reaches. A graduated scale, these liquids dilate and contract due to change in temperature. Generally, the measurement scale you use is a Celsius, although it can also be expressed in degrees Fahrenheit. These thermometers currently contain colored alcohol due to the danger of contact with mercury. The constant pressure gas thermometer. This class of thermometers can operate at both volume and constant pressure. Having a very precise measurement system, they are often used to adjust other thermometers. In this thermometer, volume increases directly with increase in temperature. It measures the temperature in the range of 0 Kelvin to 500 Kelvin. In this thermometer, pressure increases directly with the increase in temperature. The platinum resistance thermometer measures the temperature through a platinum wire that is attached to an electrical resistance that changes according to the temperature, generally used to measure outside temperature. It is a very accurate. In this thermometer, resistance of the material in a thermometer increases directly with an increase of temperature. It measures the temperature in the range of 500 Kelvin to 2300 Kelvin, degree Kelvin. So the del R, that is the change in resistance, is proportional to change in temperature, that is the del T. And where the temperature, change in temperature is equal to the change in resistance divided by R alpha. Here alpha is the thermal coefficient of resistance. Then thermocouple thermometers. These thermometers measure the temperature very quickly. They are generally used in laboratories. They measure the temperature through an electrical resistance that generates a voltage that varies according to the connection temperature. Thermocouple thermometers work on the principle of electromotive force is equal to alpha T plus beta T square. In this scale is non-linear in thermocouple. Temperature is either matched with a standard curve supplied by the manufacturer or digital display is provided. Alpha and beta depends upon the materials used to form a thermocouple. Thermocouple thermometers measure the temperature in the range of 500 Kelvin to 2300 Kelvin. In the radiation thermometers, or we can see the parameter thermometers, these measures the temperature from the heat radiation emitted by the objects. These thermometers allow them to use without having to touch objects, allowing them to be measured when they are moving or far away, as well as when their temperature are very high. This thermometer work on the principle of radiation. It measures the temperature greater than 2000 Kelvin. It uses Stephen's law, that is sigma T raised to 4. Pacifier thermometers. They are suitable instruments for infants since they take the temperature of the same without causing any discomfort. Use the same as standard digital thermometer for oral temperature. Plastic strip thermometer. Certain plastic strips applied to the body's forehead can measure temperature changes at a given moment by given a colorimetric scale that tells us after putting it on child's forehead for a minute whether a child has fever or not. However, such measurement is not reliable but indicative. So, what kind of substance should be used in such thermometers? The question arises. So, first we are taking the gas thermometers. Some substances have the property that changes with temperature. Substances that show a change in temperature can be used as thermometric material. For example, some substance expands on heating, some changes their colors, some changes their electrical resistance, etc. Nearly all the substances expand on heating. Liquid also expand on heating and are suitable as a thermometric material. Common thermometers are generally made using some suitable liquid as thermometric material. Which property should present in thermoelectric liquid? It should be visible. It should have uniform thermal expansion. It should have a low freezing point. It should have high boiling point. It should have not wet glass. It should be good conductor of heat. It should have a small specific heat capacity. These properties should be present in thermoelectric liquid. Which liquids are used in glass thermometer? A liquid in glass thermometer has a bulb with a long capillary tube of uniform and fine bore. A suitable liquid is filled with the bulb. When the bulb contacts a hot object, the liquid in it expands and rises in the tube. The glass stem of thermometer is thick and act as a cylinder lens. This makes it easy to see the liquid level in the glass tube. Mostly mercury and alcohol are used in glass thermometers. Now the question arises, with the help of these thermometers, we are measuring or we can measure the temperatures. For measurement, we require the scales, and that is called the temperature scales. So what are the temperature scales? To start the temperature scale, the temperature is the degree of hotness and coldness of an object. The SI unit of temperature is Kelvin. Generally, there are three types of temperature scales: Celsius temperature scale, Fahrenheit temperature scales, and Kelvin temperature scale. The earliest thermometer was constructed by Galileo in 1593. Newton suggested that the necessity of the fixed points. The temperature of the melting point of ice is taken as the lower fixed point, and the temperature of the steam at a pressure of 76 centimeter of Hg, that is the normal pressure, is taken as the upper fixed point. Centigrade or Celsius scale. Celsius in 1742 suggested that the centigrade system of temperature, he marked 0 at the lower fixed point and 100 at the upper fixed point. The interval between the two fixed points is divided into 100 equal parts. Each part of the degree represents 1 degree centigrade or 1 degree Celsius. The scale is also known as Celsius scale. The Celsius scale or degree centigrade is used for all popular and commercial and most scientific measurements. Andreas Celsius 1701 to 1744 was a Swedish astronomer who, in addition to developing the temperature scale named for him, made measurements of the length of the arc of median that verified Newton's theory of the flattering of the earth at the poles. On Celsius scale, the interval between lower and upper fixed point is divided into 100 equal parts. The second one is the Fahrenheit temperature scale. The Fahrenheit scale used in United States that employs a smaller degree than the Celsius scale, and its zero is set to a different temperature. Daniel Fahrenheit 1686 to 1744, exact date is 1720. A contemporary of Celsius was a German physicist who invented both the alcohol and mercury liquid thermometers and used them to study the boiling and freezing points of liquid. On this scale, the freezing point of water is 32 degrees and the boiling point of water is 212 degrees. Fahrenheit scale is divided into 180 equal parts. Third is the Kelvin temperature scale. In SI units, the unit of temperature is a Kelvin and its scale is called Kelvin scale of temperature. The interval between the lower and upper fixed points is divided into 100 equal parts. Thus, a change in 1 degree centigrade equal to charge of 1 Kelvin. The lower fixed point on the scale corresponds to 273 Kelvin and the upper fixed point is referred to 373 Kelvin. The zero on this scale is called the absolute zero and is equal to minus 273 degrees centigrade. At the absolute zero, all thermometric properties are zero. There should be no kinetic energy. And one more temperature scale is there, that is the Rankine temperature. The Rankine scale is a thermodynamic, that is the absolute temperature scale. It is based around absolute zero. Rankine is similar to the Kelvin scale. It starts at absolute zero and 0 degree Ra, that is the Rankine unit, is the same as 0 Kelvin, but it is different as a change of 1 degree Ra is the same as change of 1 degree Fahrenheit and not 1 degree Celsius. The abbreviation of degree R is ambiguous as it can also refer to the Rameau scale. Rameau scale. R is the silent. Rameau scale. The Kelvin and Rankine temperature scales are different. So that absolute zero is 0 kelvins or 0 degrees Rankine. The Celsius and Fahrenheit scales are defined. So the absolute zero is minus 273.15 degrees centigrade or minus 459.67 degree Fahrenheit. The Rankine scale was originally used in the United States. Here we are just discussing the relation between the Celsius, Kelvin, Fahrenheit and Rankine scales of the temperature. In this figure, the four thermometers are associated with the Celsius, Kelvin, Fahrenheit and Rankine. In the Celsius scale, the scale is minus 273 to 100. In Kelvin, 0 degree to 373 absolute. Fahrenheit, minus 462 to 12 degree scale. Rankine, absolute 0 to 672, that is the steam point. The temperature of the absolute 0, the melting point of the ice and boiling points of water is measured on the Celsius, centigrade, Kelvin absolute, Fahrenheit and Rankine scales are known. At 40 degrees centigrade, Celsius and Fahrenheit scales show the same reading at minus 40 degrees centigrade. At absolute 0, the Kelvin and Rankine scale agree at 0 degrees only. So this temperature have been rounded off to the nearest degrees. So we can form the relation between Celsius, Kelvin, Fahrenheit and Rankine scales of temperature is C minus 0 by 100 is equal to F minus 32 by 100 is equal to K minus 273 by 100 is equal to R minus 492 divided by 180 degree. At the denominator, 100, 180, 100 and 100 are the scale that are in equally divided. So this is the thermometry temperature and what are the types of the thermometers and what are the scales of the thermometers and how they work. Here we are taking one exercise, that is the temperature of the surface of the sun is about 6500 degrees centigrade. What is the temperature on the Rankine scale and on the Kelvin scale? So just put the formula C minus 0 by 100 for the centigrade. We take the Kelvin scale, that is the K minus 273 divided by 100. Then we take the Rankine scale, that is the R minus 492 divided by 180. Now here we are not using the Fahrenheit scale because in our exercise there is no Fahrenheit scale. Then just substitute the value, that is the C is equal to 6500 degrees centigrade. So substitute the value of C. So first equation, C minus 0. So substitute the value of C here. 6500 minus 0 divided by 100. The value is 6500 divided by 100 equals to K minus 273 by 100 is equal to R minus 492 divided by 180 degree. Take the K. So first of all you have to find out the Kelvin scale. So K is equal to 6500 plus this side goes to this side. So minus 273 divided by 100 is converted into positive. So K is equal to 6500 plus 273. We get the 6773 Kelvin. So your answer is on Kelvin scale, that is the 6773 Kelvin. Then this value is equal to Rankine. So we get 12192 degree Rankine or Emure. So this is the, you have to solve it and put the answer in our WhatsApp group, so I will check it. Thank you for watching this video on thermometry unit.